So let us begin with our activity. Here I'll present you with 3 circles and I will measure their circumference given their diameter using this device which I have made. So this device I have made with the CD and a wire. It rotates. I'll move along this and find out the circumference using this device, and diameter already I have. Then I'll be finding the ratio of circumference by diameter for all the 3 cases, right? And also I would like to tell you that this circle here, it starts with 0, and when you complete one round it equals 38 centimeters. So now let us begin our journey by finding the circumference of this circle, which has diameter of 14, as you can see here. So I'll place 0 here. I'll fast forward some part so that you don't get bored. And here we go. So what I've got is 38 centimeters of one round, and then another 5.8 centimeters, 5.8056. So let us quickly calculate 38 plus 5.8056, which is 43.8056, right? That is the diameter. Sorry, that is the circumference, and that is the diameter, 14. Dividing this by diameter, I get this value, 3.12. I'll note it down somewhere. So it is 3.1289 and so on. All right. Let's move on to the next circle quickly. This is the circumference of this circle right here, and its diameter comes out to be 3.122, right? I'll note it down. And diameter came out to be 7. It comes 3.09. I'll note it down here. All the calculations that we made using this device, it is not perfect. Even my hands, they're not perfect. So we got some human errors. But as we can see, the ratio of circumference by diameter, it came out to be almost the same number, 3.12, and so on. You can repeat this experiment with more circles. I had limited time, so I used only 3. But if you keep on doing this for many circles, you will realize that this value is actually the same. Early mathematicians realized this fact that for all circles, the ratio of circumference to diameter, it came out to be the same constant for all the circles. That is, all circles follow this fundamental property of ratio of circumference and diameter being the same, and they used this Greek alphabet pi to denote this constant, right? Here C is for circumference and D is for diameter. Pi is the ratio of circumference by diameter for all circles, and it is the same. Using supercomputers, it has been calculated to be around 3.14159 and so on. And it has been proved that this decimal expansion, it is never ending, so we do not need to worry about the exact value for calculations, and for practical purposes we take pi to be roughly equal to 22 by 7 or 3.14. But always remember that these are not the exact values for pi. The exact value of pi is very large. This has a very large, it has a never ending decimal expansion. So these approximations are handful. They come in handy. Okay, so using definition of pi, I'll show you a simple formula. Now we know that diameter is twice the radius for a circle. If I have a circle like this, then its radius would be 2 times its radius would be the diameter. So I put it here, and if I cross multiply, I get C equal to 2 pi r. That is the formula that is used for calculating the circumference of a circle whose radius is r. Now let us move on to the next topic, which is area of circles. So let us consider a circle which has a radius of r, right? Now consider the amount of paper inside this circle, inside the circumference of the circle is called the area covered by this circle. So let us consider this area to be made up of small and thin stripes, circular concentric stripes like these. What I've done is divided this circle into concentric, thin and so many and large number of stripes which cover all the area inside this circle, right? I'm telling you that I am making 3 assumptions here. The diagram is not accurate, but we have to assume that these stripes are as thin as possible and as close as possible, and they are so many in number. They are so many in number that they completely fill this area inside this circle which is demarcated like that. So all the area inside the circle is completely filled by these circular stripes. Now I'll do a simple task. I'll cut it from here like this, so that I've cut it like this, so that all the stripes, they've opened up from one end, and I'll straighten them and I'll place them one on the top of each other so that it forms a nice stack. Let me show you that. So here I cut it from there and I place these stripes one on the top of each other, so that it forms a very nice stack. And we can see that this is the smallest strip which comes here, then the next one which is bigger in diameter, and so on. The last strip, which is essentially the circumference of this, is of the length 2 pi r. The last strip, which is the circumference of this circle, these two circles are the same, it has a length of 2 pi r, right? And now consider what happens to the height of this stack. See, these stripes have some width, very small width, as narrow as possible, but they have some finite width. If I keep on adding from this end, from the center, if I keep on adding the widths of all of these stripes, I reach from here to here. That is, I cover the distance of the radius of this circle. So the sum of widths of these circular stripes which I have straightened has the sum of widths has the sum of r, right? The radius that forms the height of this stack. So if we can imagine these stripes to be so many in number, so much in number, and as thin as possible and as close as possible, so that this area of this circle is completely covered, this stack would become fine and very much finer and finer. It will keep on, all the stripes would become as close as possible, and this will form a triangle, right? Do not forget the assumptions. So this triangle has a height of r and base length of 2 pi r, and we know that area of triangle is half times base times its height. 2 cancels with 2, and r times r is r square. So the area of this triangle, which is essentially the area of this circle, since they are made up of the same stripes, which is essentially the area of this circle, came out to be pi r squared. The area of this circle is pi r squared. Thank you.